This is AS Chemistry, Chapter 1, Atomic Structure, Lesson 1, Atoms and Isotopes. Atoms are made from three types of particles. As we can see from the diagram, the center is the nucleus, which contains protons and neutrons. Around the nucleus, we have electron shells, which contains electrons, and the electrons orbit around the nucleus. The nucleus is very dense. It contains protons and neutrons, protons being positively charged, neutrons having no charge. The electrons being negatively charged orbit around it, and they have a negative charge and a very, very small mass. The electrons orbit around in electron shells, and at GCSE you will have learnt the model 2882. As you go further into this topic, you will learn that there is a new way of writing the electron arrangement, but we'll use this basic model at the very, very start to explain the principle of atoms and how isotopes work and the properties of isotopes. So we'll start with the properties of the particles, which are protons, neutrons and electrons. And in this table we have the exact mass of a proton, the exact mass of a neutron and the exact mass of an electron. As we can see, the electron is very, very small compared to the proton and the neutron. The charge of a proton is 1.6 times 10 to the power of minus 19, and the units are coulomb. The neutron, having no charge, sits in the nucleus, and the electron has the opposite charge to the proton. Exactly the same charge, but just with a different sign. It's a negative sign this time. You don't have to learn these numbers for the exam, but it's useful to have an idea of what the actual mass of the proton, neutron, electron is. And this data will be provided for you in the examination if you need to use it. When we compare the mass and the charge, we can get some numbers called the relative mass and the relative charge. This is a table that you've probably seen more at GCSE, and it compares the proton, neutron and electron and their masses and their charge. We can see that the mass of the proton is 1, the mass of the neutron is 1, and the mass of the electron is very, very small. And we quote it as a fraction, 1 over 1836. The relative charge of a proton is +1, the neutron is 0, and the electron is -1. Moving on, the atomic number is also known as the number of protons. And you can either call it the atomic number or you can call it the number of protons. And it's the number of protons in the nucleus of an atom. The number of protons also tells you what element you have. The atomic number, or the number of protons, is given the symbol Z, and it's the smaller of the two numbers on the periodic table. We can see four pictures, one of sodium, one of iron, one of tin and one of fluorine. Sodium has 11 protons and therefore has an atomic number of 11. Iron has an atomic number of 26, tin has an atomic number of 50 and fluorine has an atomic number of 9. If the atomic number changes, the element also changes. So be careful when you are writing the atomic number and ensure you copy it off accurately from the periodic table. Here is another example. This is carbon and the atomic number is the bottom number, which is 6. The mass number is the total number of protons and neutrons in the nucleus of an atom. The mass number is also the bigger number of the two on the periodic table. It's given the symbol A. And if we look at this example of magnesium, there are two numbers, 24 and 12. 12 is the atomic number and 24 is the mass number. That is the total number of protons and neutrons in the nucleus of magnesium. And here are two more examples for us to look at. Again, we've got an example of lithium and magnesium. If we look at lithium, it's got 3 protons, 4 neutrons. If we add them together, it will have a mass number of 7. And magnesium would have a mass number of 24. The mass number does not have to match the mass number on the periodic table, because certain atoms can be isotopes, which we'll find out in a few more slides' time. And isotopes will have the same number of protons but different number of neutrons, and thereby the mass number will be slightly different. So if we look at this table, this is something you can have a go at very, very quickly, and we can quickly try and work out what the mass number to these different elements are. If I run through the mass number very, very quickly, helium, which has got 2 protons in its nucleus and also has 2 neutrons. We add the numbers together and we will get 4. Copper will give us 64. Cobalt will give us 59. Iodine will give us 127. And if you look at the periodic table for the number of protons and in germanium, you will notice it is 32. The number of neutrons which we can work out is 41 if you're given that information, and therefore the mass number is 73. For the example of germanium, the only piece of information you can get from the periodic table is the mass number, being the bigger number of the two, and the atomic number, which is the proton number. This is another way of writing an atom, and where A represents the mass number, the bigger number of the two, and Z represents the proton number. X, in this case, represents the element symbol. The example below is of sodium, where 23 represents the mass number and 11 represents the proton number, and the symbol is Na. So how many neutrons do we have? This is quite a simple calculation. It's the big take away the small, or the mass take away the number of protons, or the mass number take away the atomic number. And again, if we look at some of these examples, so if helium has got a mass number of 4 and an atomic number of 2, it's the difference between the two. This would give us 2. Next one would give us 10. Strontium would give us 50. Zirconium would give us 51. You can extract the mass number and the proton number from the periodic table. So uranium has a mass number of 238 and an atomic number of 92. The difference between them is 146, and that is the number of neutrons in an atom of uranium. Remember, the neutrons can be different because if you've got a different isotope, you've got a different number of neutrons, but the proton number will always still be the same. How many electrons? The number of protons is equal to the number of electrons, only if you have a neutral atom. If the atom becomes charged, it no longer has an equal number of protons and neutrons. In this case, it becomes an ion. If we look at these three examples, they are all atoms, and therefore they are all neutral. The number of protons will always be equal to the number of electrons. Helium has 2 protons and will have 2 electrons. Copper has 29 protons and will have 29 electrons. Iodine has 53 protons and will have 53 electrons. And we can see a direct correlation between the number of protons and the number of electrons if an atom is neutral. Here is a table for you to have a look at, and usually sometimes you will be given some bits of information and you'd have to work out the other parts. In this case, the number of protons will always be the same as the atomic number. The electrons, if you have an atom, in which case they are all atoms, will also be the same as the proton number. So if we have a quick look at filling some of these numbers in, boron has 5 protons, 6 neutrons, 5 electrons. Atomic number is 5, the mass number is 11. That's the number of protons plus the number of neutrons. Potassium has 19 protons, 20 neutrons, 19 electrons, 19 as an atomic number, a mass number of 39. Chromium has 24 protons, 28 neutrons, 24 electrons, atomic number of 24, and mass number of 52. Mercury has 80 protons, 121 neutrons, 80 electrons, 80 as an atomic number, and a mass number of 201. Argon has 18 protons, 22 neutrons, 18 electrons, atomic number of 18, and a mass number of 40. Here is an exam question which is quite common on A-level papers. And with this type of question, it's important to know what are you trying to work out and what is the question asking you to do. So in this case, the question says an atom has twice as many protons and twice as many neutrons as an atom of 19 fluorine. It's important at this point to extract as much information as you can from the periodic table. Deduce the symbol including the mass number of this atom. The first thing I would do is go on the periodic table, find fluorine. You've been told it's got a mass number of 19. In terms of the atomic number, that can be found on the periodic table, and it is always going to be the same number. If you draw a table where you put fluorine, you put the unknown, you put a column with an unknown element, you write proton, neutron, and mass number, you can easily identify what the unknown element is. Number of protons has been taken from the periodic table, which is 9 for fluorine. Number of neutrons is the difference between the mass number, the top number, and the number of protons, which in this case is 10. The mass number is the combined number of the number of protons and the number of neutrons, which is 19. If you read the question once more, the question says an atom has twice as many protons. So if we double the number of protons, we get to 18. And twice as many neutrons. If we double the number of neutrons, we will get to 20. We can work out the mass number of the atom by adding the two numbers together, in which case the mass number is 38. Now to identify the element, we can't use the mass number, we have to look at the proton number, because the element always has the same proton number. If you go to your periodic table and identify the element with a proton number of 18, it will be argon. The mass number we just copy across. The mass number does not have to match that of the periodic table. It may be an isotope of the element. So what is an isotope? An isotope is an atom which contains the same number of protons but a different number of neutrons. Isotopes also contain the same number of electrons. Isotopes, however, can have a different mass number, and that's because the number of protons in their nucleus can be completely different. Here are a few examples of isotopes. These are two examples of isotopes, carbon-12 on the left and carbon-13 on the right. We can see that the number of protons is the same, hence the element must always be the same as well. The mass number, the top number, is different, and thereby it has a different number of neutrons. Carbon on the left, which is carbon-12, has 6 protons, 6 neutrons. Carbon on the right has 6 protons and 7 neutrons. And here are 3 examples of isotopes of carbon present in different proportions in the naturally occurring element. Carbon-12, carbon-13 and carbon-14. And we can see that they have different mass numbers and they have different number of neutrons, but the number of protons will always remain the same. Isotopes of hydrogen, again we've got hydrogen, deuterium and tritium, where hydrogen has got a mass number of 1, deuterium's got a mass number of 2, tritium has a mass number of 3. The mass numbers are different because they have different number of neutrons, but the proton number has stayed the same. You don't have to memorize any of these isotopes. They should be given to you in the exam. Isotopes of oxygen. Oxygen has 2 isotopes, oxygen 16 and oxygen 18. Have a think about what the number of protons, neutrons and electrons are in these isotopes. Isotopes of chlorine and bromine. These are quite common in the A-level exams, and they want you to know about the 2 isotopes of chlorine and the isotopes of bromine as well. Chlorine exists in two forms, chlorine-35 on the left and chlorine-37 on the right. In terms of their protons and number of neutrons, they're present they're 17 and 18 in chlorine-35 and 17 and 20 in chlorine-37. You also need to know the relative ratios of the 2 isotopes present in a naturally occurring sample of chlorine. Chlorine-35 exists 75% of the time and chlorine-37 exists 25% of the time. We say that there is a 3-to-1 ratio between chlorine-35 and chlorine-37. You will learn more about this when you move on to the time of flight mass spectrometry section. In terms of properties of isotopes, the properties of isotopes are dictated by the number of electrons. Isotopes should contain the same number of electrons in the outer shell because they have the same number of protons, and therefore the chemical properties of the isotopes should be identical. The only difference will be that they have different physical properties. Having different number of neutrons in the nucleus of the atom, they will have different mass numbers and therefore they will have different rates of diffusion and boiling point. This concludes lesson 1 on atoms and isotopes. The next lesson will cover time of flight mass spectrometry.